So we get a look at the application of vectors to speed, time, and velocity. So you have your vector equation, and we already know that r is the position of any vector on that point of that line. And then you have some particular point that you start with, your direction vector, and then t is your scalar. So now when we're thinking about velocity, time, and speed, what we can do is our direction vector, which is our b vector, becomes our velocity vector. And our starting point is still a starting point, but it becomes a starting point of a moving object. So for example, if you had a starting point at, say, 1, 2, and your direction vector said go 2 over and 3 up, right, then your 1, 2 plus some scalar, and we use t because that sounds like time. And then we went 2 over and 3 up. Which would mean if time was in minutes, that would mean in 1 minute you went 2 units over and 3 units up. And if you figured out the length that you went, right, a squared plus b squared equals c squared, root 13, that would be the speed that you're going, because that's how much you've traveled in 1 minute. Or if time is in hours, how much you've traveled in 1 hour. So whatever the length of your velocity vector is, that'll give you the speed that you're traveling in. And we can figure it out from there. So here's our first example. So we've got a moving object. It's starting at 1, -1. And our direction vector says we're going 3 to the right and then 4 up. And this is all in kilometers. So 1, 0 is 1 kilometer to the right, and 0, 1 would be 1 kilometer up or north. And t is time. So this is a two-dimensional question where we're working, someone's on the ground, or an object is on the ground, and it can go east, west, north, or south. So write down the velocity vector. Well, the velocity vector was the same as the direction vector. And then to figure out how fast it's going, we could just find the magnitude of that vector. Square root of 25 will be 5, so it's traveling 5 kilometers per hour. Wow. Because when time is 1, can you visualize it? Can you see 1, -1? And if t is 1, it will go over 3 and up 4. It will travel 5 units. In this case, it's kilometers in 1 unit of time, so 5 kilometers per hour. So in words, we say that it's traveling 5 kilometers per hour in the direction we can put the direction vector so we know exactly the speed that it's going and the direction. How do we change from our vector equation to this type of equation? Could start with the parametric equations, right? We've got our x and our y. And we've got 1, -1 plus 3t plus 4t. And then from there, we can solve for t in both of these cases. So the first one will be x minus 1 divided by 3. In the second one, we would get y plus 1 divided by 4. So from here, we can equate the two t's. So x minus 1 over 3 is equal to y plus 1 over 4. Multiply both sides by 3 and both sides by 4, which will give you the same effect as cross multiplying 4x minus 4 equals 3y plus 3. And the form that we were asked to put it in, ax plus by equals c. Now that is just some form of an equation of a line, just like y equals mx plus b is another form of the equation of a line. If you wanted to use your previous ways of finding an equation of a line, you knew the slope, you knew one point, so you could find the b value, and you could rearrange it from that as well. But this wasn't too bad.